డాక్టర్ సంపత్ గారికి వెయిట్ చేద్దాం అంటారా?
వద్దు సార్, స్టార్ట్ చేస్తాం సార్. యూ షుడ్ ఫాలో.
ఒక 2 minutes చూద్దాం.
సరే సార్. ఓకే.
ఓకే సంపత్ గారు. హలో. హలో డాక్టర్ సంపత్.
Sir, shall I start, sir?
Yeah.
Just
preamble 1 or 2 lines. Yeah, good afternoon to everyone.
Sama Prasad, actually we are thinking next Friday a holiday.
Okay,
we are thinking to do both of them today because
yes, sir.
Same engine.
Interrelated also.
Yes. Yeah.
That's a good thing, sir. They should not afraid that they will be sitting for more than 3 hours.
Yeah.
Yeah, just 1 minute stop change.
Yeah, it's already stopped now, sir.
Yeah. So we'll be discussing about the second experiment in the first cycle, that is to conduct a performance test on a single cylinder water-cooled diesel engine. So the make is a Kirloskar. So we'll be doing performance test as I was telling you in the previous class or in the introduction. Mostly performance tests are conducted in two types. One is a constant speed performance test, another is a constant variable speed performance test. So in a constant speed performance test, mostly we'll be concentrating on bringing the engine, irrespective of the load applied on the engine, to a specified speed. Specified speed in a sense that a rated speed. So rated power and rated speed are the specifications given as per the make of the engine. As the name suggests that we are conducting the experiment on Kirloskar engine. So the nameplate details indicate that it is an 5 HP engine. 5 HP is equivalent to 3.68 kilowatts when it is running at 1500 RPM. Okay. So with this background, we'll move ahead, and at any particular point you can stop and ask for any clarification. So as I told you that we will be conducting the constant speed and variable load. It means that constant speed means variable load. So what is that variable load? How do you load the engine? So loading the engine in a stationary engine or for an automotive engine, when you are testing in the engine's laboratory, we will be loading the engine by means of a dynamometer. So where this dynamometer is connected, at what point of time, what type of dynamometer is connected, all those things will be discussed right now. Okay. Dr. Sampath, you can go ahead.
So can you record it, sir?
Okay.
Yeah.
Shall I say once again?
Not required, sir. We have the previous recording. I can share that.
Yeah.
Have you started, sir?
Anyway, 1 or 2 points I will tell you.
Yeah.
So today we will be conducting the performance test on a single cylinder diesel engine. The idea behind conducting the performance test on a Kirloskar diesel engine is to observe the performance of an engine, how it behaves, what is the fuel consumption, what are other. So what observations we make it, and from the observations made, what are derived parameters. So those derived performance pertain to performance parameters of an engine. So basically the engine performance parameters means brake power, brake thermal efficiency, mechanical efficiency, indicated thermal efficiency, specific fuel consumption, so on. So these are the 5 derived parameters out of the 2 observed parameters we get from the conducting of experiment. So this particular engine is a Kirloskar engine. I was telling you that this is allowed to run at 1500 RPM, and when it is loaded to the full extent, it will be capable of developing the power equivalent to 5 HP or 3.68 kilowatts. So as I was telling you that performance tests are of basically 2 types. One is constant speed, another is a variable speed. So constant speed means a variable load also, and this is also sometimes called fuel consumption test. Why it is called fuel consumption test? In a short while now we will observe. And when you are loading the engine, we will make use of a dynamometer in a engine's laboratory. So how do you load the engine? Whether you load it mechanically or hydraulically or hydrokinetically or electrically or with the eddy current. So that signifies the type of dynamometer. So here we'll be showing the other end of the engine is connected to the dynamometer. For this particular engine, a dynamometer of DC shunt dynamometer is coupled. So coupled to the crankshaft end. Okay, this green color one, whatever you are seeing, is an engine. So the other components will show. Please proceed.
Just the specifications of this particular engine, wherein it is mentioned that I think there is internet issues.
Okay.
High HP engine, then it is allowed to run at 15. Whenever you install, you just have the specifications of this particular engine, wherein it is mentioned that the 5 HP engine, when it is allowed to run at 1500 RPM. So that means when you load the engine to that extent,
Shall I close and open it once again?
Supplying the
It is
fuel
streaming.
to run
Okay,
at
okay.
1500 RPM, it will develop a safe power of 5 HP.
Okay, no.
Oh, wait, sir. I have not started. I have not started, sir.
This is a crank handle or crank lever.
It's streaming, sir. I will just.
Well, make use of this lever to start the engine. As you recall that the single cylinder engines are of very low power. It can be started manually also. And sometimes you would have also observed that sometimes the small gensets nearby some shops, they will start with some small rope, and sometimes it is also practice to see some auto pullers, they start with a small rope which is connected to the flywheel. Okay, once you give some initial momentum, the engines, once the engine picks up a certain momentum, then immediately will draw. So by I was giving you an example also. If you observe the movie in olden days, example that Charlie Chaplin, with the help of a jet type of rod, he rotates the flywheel so that the engine gains certain momentum. So immediately he will take out that rod and he will withdraw that rotating of the shaft. So once engine picks up the starting on on by consuming the fuel, so it will be withdrawn. Same procedure will be followed here also. So whatever we are rotating, I showed that lever. So with the help of that one, we will try to rotate the camshaft, camshaft, and the other end is a crankshaft. So whatever that speed which is mentioned on the nameplate details of an engine represents the crankshaft speed, which is in this particular case is 1500 RPM. So when the crankshaft rotates at 1500 RPM, cams, they are the mechanisms behind operating the valves. So as you know that the inlet valve opens only in the intake stroke and exhaust valve opens only in the exhaust stroke. So these two valves will be operated in a 4-stroke engine only 2 times. So the speed of the engine is n RPM, let us say. The camshaft speed will be half the RPM, half the engine RPM. So that means n by 2 will be the camshaft speed. So the effort required to rotate the camshaft is much less than the rotating the crankshaft. So that's why the lever is provided to rotate the camshaft end, the smaller end of the engine side. Okay. Once the video starts, you will try to observe how we have actuated the engine. So it is similar to start of the water pumps by priming. You know what is meant by priming? Most of you are aware of that one. No? We pour some water so that air bubbles, whatever are there, they will not be there. So it will make us to start the engine easily. Similarly, in this case also, when you are rotating the camshaft, you are giving some initial momentum. While starting the engine with the crank lever, we will be engaging the decompression lever. Decompression lever, as the name suggests, the decompression, delinking. Okay, link, delink. Compression, decompression means you are not compressing. So that means you are opening the exhaust valve first, so that the trapped gases of the previous cycle will escape, and it will give easy path for the fresh charge to compress it, and thereby it develops the power. So there will be a lever on the head of the engine cylinder. So you carefully observe that how the engine being started manually. These are the issues you observe carefully.
Whenever you
internet setting seems to be okay here, sir, but somehow it is getting streamed.
Where from you are operating this one?
I'm from the office only, sir.
Crank handle.
Otherwise, no. Dasa's room.
Or otherwise, I will share this with you, sir. You can you see that whether you can play with it, sir? You can play from your system.
That is all possible.
Yeah. I will share this folder with you, sir.
Okay.
This will help us
No, it's not working, sir.
to rotate.
Switch off everything.
Can you manage or are you sending?
I'm trying to check once again, sir. If it doesn't work, then I've closed everything. It played last week, sir. This week, connection seems to be okay.
But the internet may be slow, no?
That can be possible. If my system is slow, then probably yours also will have the same issues.
Yeah.
Sir, its size is of 1.5 GB, sir. So I think so it takes a lot of time.
No, generally it's all 1.5 GB things that we played yesterday also. Probably I'll try to reduce the quality. That may help us. Now is it visible? Yeah. Yeah, yes, sir.
Nothing is good.
Just a moment, sir. I will share. Now it will.
Of this particular engine, wherein it is mentioned that the 5 HP engine, when it is allowed to run at 1500 RPM. So that means when you load the engine to that extent and brought the engine by supplying the fuel to run at 1500 RPM, it will develop a safe power of 5 HP.
Oh, wait, sir. I have not started. Sir.
This is a crank handle or crank lever. This will help us to rotate the engine to a rated RPM. So this you have to insert. So this is insert into this is a camshaft end. So please recall, I told you in the previous class, it is easy to rotate the camshaft rather than crankshaft, because the camshaft rotates at half the RPM of a crankshaft. So with this handle, if you give initial momentum, this will help us to give the initial momentum. So by physically rotating it, so you can allow the engine to start. When you are about to rotate with one hand, with this another hand, you have to engage the decompression lever. So while engaging the decompression lever, you have to keep it in the vertical position and give rotation to the crank handle. Okay? So once the engine gains momentum, immediately you disengage the decompression lever by bringing into horizontal position. Like this. So the idea behind engaging and disengaging the decompression lever is to easy cranking. So by engaging the decompression lever, the exhaust gases of the previous cycle will escape when you are giving initial momentum. It will allow the fresh charge to enter without any difficulty. So once the engine gains certain momentum, immediately disengage, by means of which the exhaust valve will be closed. So now it will give a room for only the fresh charge to enter into the engine cylinder for further development of power.
Please stop first. So just little go back. Yeah, as I told you, the from the camshaft end we started the engine, The left side is a crankshaft, which is connected like a propeller shaft. No, so in a vehicle also you will see that a long shaft from the engine side to the rear wheels it is connected. So here you see this dynamometer. This is a DC shunt dynamometer. So there is a larger dial here and there is a smaller dial. So larger dial will give the torque meter reading, torque. Okay. So once you know the torque and the speed, 2 pi nt by 60, there is a formula. No, so you calculate that formula will help us to get the brake power of an engine. Okay. The inner dial reading will give you the engine RPM. So the specialty of this particular thing is you need not have to have a additional a speed measuring instrument, what is called tachometer, for noting down the engine speed. So automatically this inner dial itself will give the engine RPM. Okay, that's what we are trying to show here. And you please also observe when the engine is running, so there is a change in the dial reading. So from 0 to it will be moving here and there. So that means when we are conducting the performance test, as you know, different loads. How do we calculate the different loads? So make use of this brake power equal to 2 pi nt by 60. Okay. So what is that T? T is the maximum torque and the maximum power is 5 HP safe power equivalent to 3.68 kilowatts. No. So this torque meter reading here, it is a kg force meter. So multiply by that 9.81, it will give you the torque in Newton meter. So whereas N is an RPM, which is given in revolutions per minute. So that's why we are dividing by 60. So 2 pi nt by 60 into 1000, 60 by 1000 into 9.81 will give you the power reading. So that means from that you evaluate the maximum value of torque. So when you have equated it to 3.68, no? So you come out with a value equivalent to 2.48. Okay, 2.48 kg force meter. So this 2.48 for facilitating the experimental conduct experiment. So we'll be dividing into 5 or 6 divisions: 0, 0.5, 1, 1.5, then 2, 2.5. Like that, we'll be loading the engine. At every point of loading, you will bring the engine to the rated RPM, that is 1500 RPM. And so far, when it is running at one particular load, so you are maintaining the constant speed now to satisfy our objective. So once you load to the next step, so far the engine was running at the previous load. So, but when you load the engine to the next load, the engine speed will fall. So to compensate for the loss of speed, you will once again allow the more fuel by adjusting the fuel rack. So all these things you carefully observe. Then if you get any doubt, no, I'll explain further. Please carry on.
Of the engine, nameplate details of the engine will help us to calculate what is the load by which I can load the engine, so that the engine will develop a power equivalent to 5 HP when it is allowed to run at 1500 RPM by supplying the fuel. Okay. So for observing the engine behavior at different loads, you have to divide the maximum load obtained from that formula 2 pi nt by 60. multiplied by some conversion factor equivalent to 5 HP. So we will be able to get the value corresponding to this 2.42 kg meter. This is corresponding to the meter reading what is going to be shown. If I load the engine to 2.42 kg meter of torque and allow the engine to run at 1500 rpm by supplying the fuel by varying the fuel rack position. The engine is about to show 1500 rpm here and developing the power equivalent to 5 HP. Okay, so at that time you have to measure the time taken for cc of oil with the help of stopwatch.
See the inner dial reading also. It has changed to 1500 rpm, and there is a lever here now with the help of bellows. Now you can adjust so that the more and less fuel can be regulated. That is entering from the fuel tank through the plastic tubing through this fuel filter. Fuel filter as a bottom, and from the fuel filter it enters through into the fuel pump to the injector, which is located on the top of the cylinder head. So whereas this rack pinion arrangement is there, so this will regulate the amount of fuel. In an actual engine, what happens in a diesel engine, when you press the or withdraw the accelerator pedal, more or less fuel amount of fuel will be entering the engine cylinder. So this is how this is connected to the accelerator pedal. Here we are conducting a performance test in a laboratory. Manually we do this adjustment. When we are changing to the next load, you will also observe that our mechanic will be operating through this adjustment of fuel rack position. Please. See, there is a change slightly it has moved. It has come to 0.5 kg force meter. It has moved to the next reading, next step of reading in our rack. So this is one you are able to see now. This is a 0.5. So we are trying to adjust the speed again 1500 rpm. This is a dynamometer panel where you adjust the resistances. V equal to CR, no? So V is the main supply, it is 220 volts, it's coming, and C is a current. How do you adjust the current? By maintaining the constant load by varying the resistances. So this DC shunt dynamometer will help us to apply large amount of resistances so that current can be varied. So that is what is one of the DC shunt dynamometer means. So this is a panel. Okay.
Sir, this is one reading that we have taken for 1.5 Newton meter
Okay.
and 1500 constant rated speed. How we have shown how the fuel measurement was taken, sir. Can you explain? Should I repeat that, sir, so that you can give an overview?
Shall I give explanation?
Yeah, on the video itself, you can do that so that if
Okay.
anyone has doubts, it will be clear. I'm just repeating it, sir. Yeah. So for 1.5, we are taking videos.
So initially when we started the engine, there was no load because the dial was at a 0. But when we started supplying the fuel, engine means we started the engine now. So we brought the engine to 1500 RPM. So we allowed it to run for some time so that the engine will start consuming the fuel. And here there is a burette, it is a volumetric flow of a fuel which is passed through the engine. So we are trying to bypass the fuel supply because there is a 3-cock supply is there. So when you bypass the fuel, so that it will pass through the burette, and we can take the time taken for 10 cc. Normally we have to take for time taken for 30 cc of fuel consumption, so that the engine consumes sufficiently good amount of fuel. So the moment if you recognize some point here without any parallax, let us say when it was coming down, it is an 100 cc burette, let us say. So at a point which is convenient to you, at 40 cc you have started. So you start the stopwatch. So this is how the stopwatch is started. So that means from 40 to 10 cc, it covers a distance of 30 cc within the burette. So time taken for 30 cc of fuel consumption in and down. So these are the load is 0. So that means once you take the time taken for 30 cc, you have done with that particular load. Then what do? You try to adjust the fuel rack so that we can go to the next step. In our next step, it is a 0.5. So we have not shown 0.5 because you could see now the dial was running at a 0.5 and 0.5. The next load is again 1. So next another reading is 1.5. So we will try to show at 1.5. So once you go to the every step of load, there will be fall in speed corresponding to the previous load. So we have to compensate for the loss of speed because our objective is to conduct the constant speed performance test. So what does it mean constant speed? The engine will be taking the same amount of air irrespective of the load. That is a specialty of a diesel engine because in the suction stroke only air enters into the engine now. So irrespective of the load, same amount of air is going. So what is happening? Air fuel ratio is varying. So air fuel ratio along with the load will be varying. Those are all the different derived parameters. Of course, your classmate is there here who belongs to A section, Mr. Moni. We asked him to come to the laboratory. So he is also taking readings along with us. So these are all the different arrangements which are there. This is mounted on the test bed. Anyway, okay.
You can say that 0.5.
Dr. Sampath, shall I continue or?
Yeah, it's done, sir. Almost. We have shown one reading.
Yeah. So likewise, every step you will change the load. No?
We come to the kg meter and next load is 1.5 kg meter. So till we come to the 2.4 kg meter on the top meter. So likewise we get about 6 readings. So these 6 points will help us to draw the graph with respect to various parameters like thermal efficiency, both wake thermal efficiency, indicator thermal efficiency, mechanical efficiency,
Specific fuel consumption.
specific fuel consumption versus
All this.
The previous video has come out without any
fuel
interruption.
consumption versus breakover, if you draw, then the procedure will be explained. So as detailed below. So this will help us to approximately calculate the friction power. So this is the approximate method of arriving at the friction power of an engine at a given speed of an unthrottled engine. This is a diesel engine now. It is commonly called as unthrottled diesel engine. So this engine, while stopping the engine, we should not abruptly stop the engine. So slowly cut off the fuel supply and bring the engine to the 0 RPM, and there ends the completion of the experimental Correct. Okay. Whenever you
Sir, now I am showing the readings, sir,
Yeah, sure.
with the respective calculations.
Yeah, tabular column, no?
Yes.
So at this point of time, if anybody is having doubt, no? Anybody, any clarification?
So these are the set of observations, sir.
Yes. So it's a torque meter reading, it is a 0, no? So there is a time taken for 30 cc of 10 cc of fuel consumption equivalent to 64 seconds. Okay. And here you have next load is, because load is varying and time is also varying, you see. But the amount of fuel consumed is same, and the speed is of engine is also maintained constant, 1500 rpm. And these are all the parameters through which we can do it. So I'll try to show it how we arrive at the friction power of an engine with the help of some calculations on the board. Is it okay, Dr. Sampath?
Sir, yeah, sir, I can play that, sir.
Yeah, that's why I'm asking before going to the calculation. If anybody is having doubts, no, they can ask.
Should I put that calculation part, sir?
Yesterday we have.
Yeah, that directly I'm starting.
That. So as we decided, no, because next week is also going to be holiday,
holiday.
Friday, and anyway some calculations of how we have to perform will make you to complete the calculations of this particular experiment, and also simultaneously the conduct of motoring test will also be explained to you. So how do we conduct the motoring test will also be related to the performance test. How these two are interrelated, what is the theory behind this one, I will explain now. Good afternoon, everyone. So today, just recollecting what we have done in the last class, we conducted an experiment on Kirloskar engine. So the main objective of the test was to draw the performance characteristics by conducting a performance test on a single cylinder diesel engine. It is also called fuel consumption test because we conducted the constant speed test. So by varying kilowatt, we did the constant speed test. And by taking the readings with respect to for every torque meter reading, we noted down the time taken for some fixed amount of fuel consumption. So let us tabulate those values. How the tabular column is right, I will just brief you. The serial number anyway is there. The torque meter reading, so which gives the torque meter reading, the outer dial reading, no? The larger dial reading gives you the kg force meter, and here we have time taken for 10 cc fuel consumption. These two are observation values, and in every torque reading we maintain the engine speed to constant speed, that is a 1500 rpm in this specific case. So let us say by supplying some amount of fuel, by adjusting the fuel rack, you allow the engine to bring it brought to the 1500 rpm. So may allow the engine to run for some time, then take time for 10 cc of fuel consumption. Note down that value. Let us call it as a T1. So then allow it to run for some time. Then what do you do? Our test, because we understood that it is in a 5 HP engine. So what is the maximum torque corresponding to this 5 HP? We calculated from this formula. So that accounted to be 2.38 kg force meter. So like 0, 0.5, 1, 1.5, 2, then 2.38 or 2.48 is the last rate. So let us say, so far the engine was running at a constant speed with no load. Now we have noted down the time taken for 10 cc fuel consumption. What do? You go to the next load. Because having divided in equal values, go to the next value. So by adjusting the fuel consumption, you get it to 0.5. What will happen once we load the engine from external source to the resistances and a DC shunt diameter, the
engine speed will fall and try to compensate for the loss in speed by adjusting the fuel rack so that again engine will be brought to 1500 rpm. Allow the engine to run for some more time so that it is steadily running at 1500 rpm per second. So irrespective of what does it mean? Irrespective of the torque meter reading, every time you have to bring the engine to 1500 rpm by noting down the time taken in each case. Okay, so T1, T2 corresponding to 0.5 torque meter reading, T2, 1, then T3, so 1.5, T4. And 2.5 let us say. So whatever that is a T4. So note down these values. So now you come to the calculations. So next step is because you know only the variable is here is a torque. So we maintain the speed as constant. This formula. The only torque is value. So for the first reading, when you put T equal to 0, the whole value is 0. So brake power is 0. So what is the 0.5 is the next torque reading. Substitute that 0.5, calculate this value, we get the value of BP1. Okay. Likewise, 0, BP1, BP2, BP3, BP4, so corresponding to the last two torque meter reading. Similarly, we got FC1, FC2, FC3, FC4, FC5. Okay. So now, after this, how do you calculate the fuel consumption? Fuel consumption is nothing but only time taken is you have noted down. For how much fuel consumption? It's a 10 cc. So 10 cc divided by seconds. So many cc per second. So to convert that into grams, we have to multiply with its specific gravity. So 832 kg per meter cube or 0.832 is the specific gravity of a diesel fuel. Typical diesel fuel in our laboratory, whatever we are using. So now, up to this, what you get? So many grams per second. So these grams have got to be converted into kgs divided by 1000 per ton. So now kg per second. So to get it into kg per hour, you have to multiply another conversion factor from seconds to minutes and minutes to hour. So you get the 2600. So in effect, you get the fuel consumption. So note down all the values, calculate all those values for fuel consumption. So now what is the fuel consumption for every torque meter reading? So now you have to forget about torque meter reading. You have to now concentrate on brake power and fuel consumption. Let us come over here, draw the curve to get the approximate value of friction power. This fuel consumption.
Yeah. At this one, please stop at this one. So as I was telling, no, because the observation values are only torque meter reading and time for the fixed amount of fuel, like 10 cc. So from that we calculated fuel consumption, and from the torque meter reading we calculated the brake power. So how these two will help us to get the approximate value of friction power. So there are different methods to arrive at the friction power of an engine. One of the simplest method, and which doesn't require any special method arrangement to arrive at the value of friction power, is to draw the fuel consumption versus brake power characteristic. This is very popularly called Whelan's line method. Okay. So how this curve looks like now, I am trying to explain you. Please.
For this graph, the x-axis, this will give the value what I have shown, the torque line. So this is line what is popularly called Whelan's line method. This Whelan's line method is because the fuel consumption versus brake power. So you need not have to go to a specialized method for conducting getting the value of friction power of an engine. So by conducting the performance test itself, it will give you the friction power. So we are indirectly getting the friction power of an engine. That because this is applicable for engines which are running at constant speed, and moreover for unthrottled engines or diesel engine is an unthrottled engine. Likewise, you get the curve here. So by extending the linear portion of the curve, as I told you in the previous class, you will get this value, and this value is a constant value because it is maintained constant, speed is maintained constant. This value needs to be added to every brake power value to get the indicated power value for every torque meter engine. Brake power 1, brake power 2, brake power 3, brake power 4. So likewise you should have got these values. Okay, if you are, because when there is no power, but still the engine is consuming some fuel. That fuel, whatever it has consumed, when the engine is not loaded, when it is running under no load condition, because we are not getting the power from its shaft, but still the engine is consuming some fuel. So whatever the fuel consumed by the engine under no load condition is just to overcome the friction. Okay, that is the idea. So that value is here. So when corresponding to the Vp0, we have what is this value? This one is of. Okay. So then what is the next value? Next value is some, you will get it like this. So next value is here. So next value is somewhere here. So next value is somewhere like this. So if you draw this one, you may get a value which is like this. Okay. So this value will be something like this. The curve, normally we get it like this. So if you carefully observe this trend of this curve, one part of the curve is almost linear. Okay. And this curve here, it is not linear, it is not straight. And when you go to the higher loads, it is also not straight. Okay. So you have to, this approximate method tells us you extend the linear portion of the curve. Okay. So that is the better method. Extend the linear portion of the curve so that it cuts the negative power axis. So this can be approximated as a friction power. Fp. This is the approximate. Now somebody may question why we have to extend the linear portion of the curve. Let us say if I get it, the curve which is in a straight line only. Normally the fuel consumption and brake power will not go linearly. It is not a linear curve. Y equal to mx plus c. Is it? C value we are getting now this one. Okay. So mx value means it is in a straight line. We may not get sometimes. So in that case what you have to do? You have to draw a tangent at 75% of the power. So this maximum power or rated power is equal to 3.68 kilowatts corresponding to the 5 HP, which is shown on the nameplate details of an engine. Okay. This 3.68. What is the 75% of the 3.68? Somewhere you may get it here. Okay. So if you draw a tangent at that point, it almost cuts like this. Suppose if you draw a tangent somewhere here, so this curve is, this method is very very sensitive to the drawing of a tangent. Instead of drawing a tangent, what we are trying to do is we are extending the linear portion of the curve. Okay. So if you get it, a value somewhere here, and that value is Fp, friction power, should be approximately equal to or less than 25% of the rated power, rated brake power. So what is the 3.68 half? Is it 1.78? 1.79, no? Am I right? 1.89, 85. So you may get it around 0.9. Okay, very near to 0.9 kilowatts is the 25%. So that is a maximum. Suppose if you are getting this linear portion of curve extends here, so this is almost accounting to the half of the brake power. So then are we ready to sacrifice the friction power to the tune of 50% of the brake power developed by the engine? No. Similarly, if you draw a tangent, it comes for somewhere here. So you have to play with the drawing a tangent in such a way that it almost very near to less than 25%. But don't see that it is almost equal to 0.05 of but don't be too much economical. At the same time, don't too much liberal to give friction power. Okay? So it should not exceed 25% of the brake power, rated brake power, safest power. So this is because while conducting the performance test, we get a crude value or approximate value of the friction power. Okay. Now our third experiment in the second cycle is to conduct a motoring test on an engine or retardation test. So what are the different methods available for one to
Sir, so far we have completed the constant speed test, sir.
Constant speed test.
Yeah.
So the idea behind drawing the fuel consumption versus brake power characteristic is to get the value of a friction power. Okay, what is the use of that one? So that value is very much useful because we ran the engine for a constant speed condition, no? So as long as the engine speed is constant, the friction power is also constant. That is an approximation, and that is a well-known fact also, because it is a strong function of speed only. So this particular friction power, whatever we obtained from the fuel consumption versus brake power curve, so that value will add to every brake power. Because again, I am stipulating the condition that this is a constant speed test. So let us say 0 is the first brake power value, no? When no load was there, but of course fuel consumption is there. That fuel consumption, whatever the engine has consumed, it is only to overcome the friction losses in the beginning. Okay. So initially, whatever 0 plus, because brake power plus friction power is nothing but indicated power. So indicated power at a no load condition is equivalent to friction power only. So then next value, next BP1 we got, no? So that BP1 plus your FP, again the same value, whatever you get. So you will get the IP1. So IP2, indicated power, second reading. IP3, IP4, IP5. So whatever IPs, whatever you will get it here, and BPs are there. So BP by IP will give you the mechanical efficiency. Okay, am I right? So that is a significance of calculating the or approximating the friction power. So then I'm trying to show here, you see, mechanical efficiency. Okay, so we have drawn that with respect to every brake power value. So whatever mechanical efficiency has been obtained, is that first curve is this one. So next one is the brake thermal efficiency. How do we calculate the brake thermal efficiency? Any efficiency is nothing but output by input. Output here is brake power. Brake power by heat input. Heat input is mass flow rate of fuel consumption multiplied by calorific value of fuel. So brake power by mass flow rate of fuel consumption into CV into some conversion factor, because BP is in kilowatts, the denominator gives you kg per hour into kilojoules per kg, so kilojoules per hour. So you convert it into 3 seconds. So units consistency will be there. Otherwise it cannot be a non-dimensional parameter efficiency. So for that, what you do, BP into 3600 into 100 divided by mass flow rate of fuel in kg per hour into value, which is in kilojoules per kg. So this also can be written like 1 upon mass flow rate divided by brake power. So mass flow rate by brake power does that. Okay. So for a given engine, as long as the same quality of fuel you are supplying, calorific value is also constant. So it means that your brake thermal efficiency is inversely proportional to specific fuel consumption. So specific fuel consumption calculation, how do you deduct fuel consumption by your brake power? No. So fuel consumption at no load, some value you got it. So no load fuel consumption value, some FC1 divided by 0 means infinite. Infinite means it will start with some asymptotically very high value, but as you are gradually loading the engine, the fuel consumption will get reduced. So engine will be developing also the power. A stage may come where it will reach a minima. And if you go trying to load the engine beyond this rated capacity, of course, engine will develop power, but at the cost of heavy fuel consumption that reflects in the form of a thick smoke emanating from the exhaust pipe. Of course, we are not bringing the engine to this state. We are trying to stop at this point. This you have to appreciate that the brake power is increasing, your fuel consumption is continuously dropping. Specific fuel consumption. See, this specific fuel consumption is different from your ordinary fuel consumption. Specific fuel consumption is a very good parameter to say that whether the engine is a good or bad. An engine which is having a high brake power, you cannot say it is a good engine. And at the same time, engine which is consuming only a small kg per hour of fuel, that cannot be efficient engine. So for how much flow rate of fuel it is developing 1 unit of power. That is a better indication to compare any two engines. So in terms of fuel consumption, it is not that only fuel consumption. what we here, it is a specific fuel consumption. This is a normalized parameter. Then once you get the thermal efficiency for every x-axis, no, you are plotting this graph. So it is starting from 0, you have got this trend. And next you go to the indicated thermal efficiency. As I told you that when you added 0 to your friction power, initially indicated power it is obtained. So it starts with some value here on the FY axis. So it is there. So at every point it is nothing but friction power. Okay, these two go parallel but with this value. Then anyway, I explained you about mechanical efficiency. So to arrive at these values, you require friction power values. Okay. So now I'll tell you how do we conduct the motoring test. Please. Any doubts at this point? Hello, all of you are there hearing?
No, sir.
Not
No, sir,
hearing?
no, sir.
Not hearing?
Audible, sir.
Audible means no doubts. Okay.
Shall I play, sir?
Thank you. Yeah, please.
Conduct experimentally. Okay. One is motoring test. Motoring test. The second one will be retardation test. Retardation test. The third one is Morse test. Morse test. And fourth one, I don't say fourth one, but so we are calling it is 1, this is 2, then 3, the 4. So 1 is the approximate method, fuel consumption versus brake power now. So this is what is called Whelan's line method. Whelan's line method. So this curve is called Whelan's line. Whelan's line method. Okay. So for the Whelan's line, we get some approximate value of that method. So how best we get from the motoring test? What is the value given from retardation test? What is the value obtained from Morse test? Of course, we have one limitation on a Morse test. This is for multi-cylinder engines. This is a multi-cylinder engine. So we have conducted a fuel consumption test. Performance test is also called fuel consumption test, or that is a constant speed test. Constant speed test. This Whelan's line method holds good only for the constant speed operation and mostly for unthrottled engines. We are not throttling the incoming charge of the engine. Unthrottled engine. Diesel engines are known for unthrottled engines because we allow the engine to take as much as air as possible. Further, the Whelan's line method is very much suitable for getting the approximate value of the friction power. Okay. So this is one method. This we have already drawn, I hope, by calculating the different parameters here. And how do we do this motoring test? Motor, let us understand the meaning of motor. Motor means some electric motor. So as you know that we conducted the performance test on a Kirloskar diesel engine, which is provided with a DC shunt dynamometer. Okay. So this DC shunt dynamometer means an external source, electrical motor. So this motor permits us to run the engine initially. So it drives the power from the mains, and when it is required, it stores in the form of the generator. When it is required, it works like a motor. It works, gives us some mechanical energy. So for that, what do you do? In this constant speed test, if you remember, we ran the engine to bring the engine to 1500 RPM, irrespective of the torques. Okay. So in this also, if I allow the motor to run the engine in a very short duration, so that the engine can be brought to 1500 RPM, by cutting off the fuel supply, the meaning is we don't want to supply the fuel, but we want to run the engine as it was running at constant speed test. Okay. So by bringing the engine from external source, the power supplied from the external source, how much power it is drawing from outside is nothing but it is an indication of the friction power developed by the engine when it was running with the fuel consumption at the same speed. Then another advantage of motoring test is we can also get the friction power at other speeds also. Let us say I am interested to know friction power developed by the engine at a lower than 1500 rpm or higher than 1500 rpm. Likewise, I am interested at 1000 rpm. I will try to supply the power from the external source through a motor and try to bring the engine to the condition of 1000 rpm. At that time, what is the load taken by the engine temporarily? That is an indication. Load is not for torque. That is a dynamometer is provided the torque meter. That torque corresponding to the torque, taken from external source by allowing the engine to run at 1000 rpm. Okay. So note down that value, calculate the brake force. Again, go to the 1100 rpm, note down the torque meter reading. Go to 1200 rpm, note down the torque meter reading. As you are going down the speed versus the torque meter reading. So 1000 rpm, then what is the torque? 1100 rpm, what is the torque? 1200. Likewise, you go up to 1500 rpm. Because we have a value at 1500 rpm which is given by our Whelan-Slide method. Okay? So whatever value it has taken, it has obtained from the friction, the fuel consumption method should be equal to the motoring test method. You know pretty well that motor may not be working with 100% efficiency, so it will have some motor efficiency. Whatever value we get it power divided by that motor efficiency, so actually it is supplying, it is drawing that much power. So please note here that we are running the engine without supplying the fuel. So engine will also be running without taking the lubricating oil. So if we run for more time by taking the power from external source, we will be unnecessarily generating more friction. So only caution here is to complete the test as early as possible so that the friction will not be.
So at this point, I want to tell you that the four methods I mentioned now here, fuel consumption, which is called as Whelan-Slide method. The second one is motoring test. The third one is retardation test. The fourth one is a Morse test. These are all the approximate methods only. The approximate of the approximate is a very crudest, that is a Whelan-Slide method. I told you, it is very sensitive to the time, the point of drawing the tangent, how exactly you try to alter your value so that it cuts the negative intercept of your power axis. So it is very sensitive to that tangent. So that is one way. And what are all these methods? These are all indirect methods. These are called indirect methods. If they are indirect methods, is there any method what is called direct method? Yes. What is that direct method? If you have a pressure transducer which can sense the pressures of an engine cylinder right from the beginning of suction stroke to the end of exhaust stroke, so the engine will be completing, in the case of a 4-stroke engine, 4 strokes. So it will be covering about 720 degrees. For every degree, if you can capture the pressure inside the engine cylinder, so that is amplified with the help of a charge amplifier. So those values, if you get it, and you can convert the crank angle into volume. So you know pretty well that it is a 4-bar chain mechanism. No? So crank slider mechanism where we have volume of theta. It is a function of theta, from top dead center to bottom dead center. It is traversing like a crank slider mechanism you have done in kinematics of machinery. So some conversion is there from theta to volume or vice versa. So likewise, you get what is called PV diagram. The PV diagram, very popularly called indicator diagram of a particular engine. Let us say in a SI engine, the Otto cycle we have to run, that is an indicator diagram of a petrol engine. Typical petrol engine, a standard or thermodynamic cycle for a petrol engine is an Otto cycle. So what is a diesel cycle? Representation of 4 processes on a PV diagram, PV plot. So that PV plot is nothing but it's your PV diagram. So that PV diagram, in a sense, it is the indicator power. So from that you will get the indicated power. So power developed inside the engine cylinder, power developed outside the engine cylinder or outside the crankshaft is available to the user end. So the difference between these two is friction power. So this is the direct method. All these four methods listed here we can compare with the help of this direct method. Okay, so that means it requires a sophisticated instrumentation like a pressure transducer and crank angle marker, so that one can arrive at the indicator diagram. As you observe that there are so many arrangements on an engine wherein we can get the water flowing into the engine cylinder at what temperature, engine flowing out of the engine, exhaust temperature leaving the gases, the exhaust temperature of the gases leaving the engine cylinder, and there is a provision to also locate the pressure transducer. So many provisions are there because we were conducting research type of experiments also on this particular engine. That's why so many arrangements you are able to see on that engine. But when the time permits, no, we will be conducting motoring test, Morse test. So I have already briefed you about the motoring test. Now we will try to show the values obtained from the motoring test. Okay.
The first we will show the video, sir, how the loading is done, and then I'll show.
Sure. Thank you.
It's loading the engine, sir, motoring test.
Speed is very near to 1000 RPM. 1100 RPM. So correspondingly the torque meter reading is observed.
1400 RPM. Now they're showing the motoring switching on. They're stopping the engine.
So you will be sharing the values, no?
Sharing the constant speed test values now, sir.
Constant speed test values. Okay, you
Yes, sir.
already showed now. Then
Constant
motoring test also.
motoring test, sir.
Oh, they are not noted down, no?
Yeah.
Okay. Any clarifications on to see?
So please note down the observations for the constant speed test. This week you have to submit this record along with the necessary curves. And motoring test results I will give you by Monday. And then you can prepare the record and submit it by the coming next Friday.
Seer of the class is there?
Yes, sir. Kalyan, sir. Kalyan.
Kalyan, I'm
Yes,
trying
sir.
to see only because including our faculty members, we are 62. What is happening to the remaining people? We are 88 number, no?
Yes, sir. Some people have network problems. So
See, you will have network problems, and finally you blame us that why this is online laboratory is there. So if you are willing to come, you cannot come. huh? So finally you try to blame the faculty only. What is that, Kalyan?
yes,
You will not blame us?
I'm informing in groups, sir, but many people.
If there is an exam or intern or something, nobody will have problem. They will manage somehow.
Yeah, exchange of information. See, from your comfort zone only, you can sit and listen to the class, no? What is that? Simply abstaining from the classes. Some information sometimes, no, it is not available in the textbook. Those you will be sharing with you.
Yes, sir. I will inform in the class. Next time I will read out. You won't be.
Yeah.
Not some information, sir. I learned so much from my side.
Yeah, because
Yeah.
cannot be masters of anything, no? Everything. At
Yes,
least,
you are saying so many things, comparing the physical to the laboratory. So that part will
actually,
not be explained in any textbook. So
somebody is writing, Karthik, what should we take value of density of fuel? I said no, 832 kg per meter cube or 0.832 is the specific gravity of fuel. Specific gravity.
I hope you have taken the reading, sir. Is that fine?
Simply snapshot now they have to take.
Yeah, correct, sir.
Can anybody respond whether you have noted down or not?
Yes, sir. I know.
Say, as I explained you that brake power in kilowatts, BKW means. So N value is 1500 and torque meter reading is torque readings are there now. So into 9.81 then finally it comes around your brake power in kilowatts. Then fuel consumption here. Of course, we have taken for 10 cc, you have to take only 10. Here it is written 45. Don't do 45, okay? So be careful in making use of the proper cc. Okay, this in place of rho, you have to take 832 because 10 power 6 we are doing now. Otherwise, 0.832 divided by 1000 only. So there ends that one. Then indicated power is nothing but BKW plus frictional power. This friction loss is obtained from the valence line by drawing the fuel consumption versus BKW as I explained on the board. So then whatever we get now, fuel consumption divided by brake power is nothing but your specific fuel consumption, this value, kg per kilowatt hour. So brake thermal efficiency. So this is the formula and explanation as I explained you. Brake thermal efficiency, indicator thermal efficiency, mechanical efficiency. So for every reading, so these are the serial number, load, or that is a torque, then time taken for 10 cc, fuel consumption, brake power, then indicated power, then the brake thermal efficiency, indicated thermal efficiency, mechanical efficiency. That's all. These are the calculated parameters you can all tabulate. So those draw this. Please don't use your Excel. No, you have good capability of using Excel plots, but draw on a graph sheet. Okay, graph paper. So try to upload the graph paper on drawn graphs only. Don't copy from your friends. Try to take your own scale, draw the graph, how it is going to be. Draw the fuel consumption versus brake power on one graph sheet, remaining other graphs on another graph sheet. So that because here you have to take the negative intercept value, so it will otherwise it will be too much clumsy. So that's what I wanted to tell you. It's okay. While switching off the engine, there is a spark. Anyway, that is now on the panel. It is not our mistake or anything. Sometimes it happens. Overflow of current. Calorific value of fuel is 43626 kilojoules per kg. So it is a silent asking of questions through chat box.
Calorific value.
They are very silent.
Yeah,
And asking the
calorific.
questions.
So I will tell you. I will tell them. Sir.
Kg. 43,626. Anything else? Amarnath Biswal.
Yes, sir.
Yeah, last class you asked some questions. No? Anything or you clearly understood what we explained? Okay, Dr. Sampath.
Yes, sir. So calorific value, how much, sir? Is 43,626 is what is mentioned in the manual supplied to them.
Correct.
So in kilojoules, 43,626
Correct.
kilojoules per kg. Yeah. Yes. Yes, sir. Then if they don't have any doubts, we can wind up the session.
Gupta sir, would you like to say something?
There is nothing.
These people are very silent. They are electric vehicles, I think. They don't emit noise.
I think they are feeling weakened already.
There is a WhatsApp message, sir. When it is coming to the Monday, no, people will be very, very dull. When they are approaching Friday, no, they will feel very happy. Because now, but our students are. Shall I stop recording?
Yes, sir. Yes. So constant speed test monitoring, constant speed test you have to submit by next Thursday, around 12 p.m. I will give you the time. So please make sure that you submit the records in LMS. Okay. Monitoring test from Friday onwards, next Friday onwards, I will open the assignment link. In that you submit.
Okay.
Okay. So, sir, anything more, sir?
From my side, I have done.
Yeah. So,
Unless any specific clarifications are there, no?
I think more or less. Gupta, sir, can we wind up the session, sir?
Okay, we can wind up. Only when they do it, they may get some doubts. Now
Exactly.
they may not get.
Yesterday's batch, they have done calculation. When we explained, they committed some mistakes. There was good interaction yesterday.
Yes, sir. Yes, sir. But because we have not explained them how to draw the curves and all, sir. So in this class itself, we have they are well aware of how to draw and also probably. Again, this is a continuous class, so they don't have too many doubts.
Otherwise, what we would have done is because if there is a restriction on Google, no, otherwise we would have combined these two laboratories together, A and B sections.
Yeah, then we may have to.
They should also be free, no?
Yes, sir. That is the problem. Kalyan, are you free on Thursday afternoon?
No, sir. We have MTM labs.
Yeah. So, but Google Meet restriction is also there, no?
But we can do it in WebEx also, no, sir?
WebEx, yeah.
WebEx or Google.
Recording option is there in?
Yeah, it's there, sir.
In WebEx.
But yes, sir. Because since they are staying for less time, the data may not be also too high. I think. Kalyan, isn't it?
Yes,
most
sir.
of the students complain about WebEx is that it discharges their data compared to Google Meet. But in WebEx,
Some faculty are using WebEx on this.
Yes, sir.
Combined classes, no?
Yeah, all combined classes they are run by WebEx only.
Yes, sir.
What is the restriction? 500, 500 members.
No limit. Actually, our college people are doing with the whole students. There's no restriction at all. We have purchased it.
We have purchased rights for WebEx or
So
college.
we don't have any limit.
Okay, sir. Okay, sir. Okay, sir. Then next week we can decide, sir, what can be done. If MTM lab is separate again for you
Yes,
and
sir.
the B section.
Kalyan, usually MTM lab, how much time it takes?
It will take 1.5 hours, sir. At least.
So probably,
if possible, chepan.
Probably they have MTM labs on simultaneous days for B section on Thursday and A section
Yeah,
on.
same thing.
yes,
I know.
so
I know. What
they
we
can
can
talk-
do is After that 1.5 hour, another 1.5 hour, if we take both labs, they can complete in one day. Both of them.
Sir,
Yeah.
sir, both the professor is same for both the sections, sir.
That's what.
Then you can
Easy
talk, no?
combining? Easy combining?
No, sir, not come. We'll ask him, sir, once.
Yeah. If he also combine, we can continue like that. 1.5 hours he can take, and 1.5 hours we can take, and we can close it. We can see whether it can. Who is that teacher?
Sadasivara, sir.
Okay. We will talk with him, and we will see. Okay.
Machine tool and metrology lab, I think.
Yeah. Machine tools and metrology, right?
Yes, sir.
Okay, Kajan, right?
Yes, sir. Thank you.
Okay, see you all.
Okay, sir.
Thank you, sir.
Thank you.
Thank you, sir.
attending.
Thank you, sir.
Thank you, sir.
Yeah. Thank you, Ambaprasad sir. Thank you.
Yeah,
Gupta, sir.
thank you. Thank you, sir.
We'll